Hello, everyone. My name is Molly Halsey, and I'm the event specialist here at Enterprise DB. I will be your host today for our webinar, How to Use postgresql.conf to configure and tune the Postgres server. I'm joined by Mark Linster, EDB Senior Vice President of Product Development, Bruce Momgen, co-founder of the PostgreSQL Global Development Group and database architect at EDB, and Raghavendra Rao, managing consultant in the professional services division at EDB as well. Before we get started, I just want to go through a few housekeeping items. This presentation is being recorded, and we will be sharing the recording along with the slides after the broadcast. Can we hit the next slide real fast?
I'm sorry. Yeah.
The lines are currently muted. If you have a question, please feel free to submit it in the question panel. Today's session is scheduled for 45 minutes. We expect the presentation to last most of our time today, and we will allot any extra time for Q&A. If we do not have time to address all questions, we will follow up afterwards with anyone whose question was not answered. So coming up, we have webinars in the future.
Okay, so this is part of a series of webinars. We 2 weeks ago spoke about how to use Terraform and Ansible to deploy highly available Postgres. And again, the recordings, as Molly said, are all available. The slides are available, so you can get all that stuff. Today, Raghav will talk about the postgresql.conf file and how to use it for tuning. In 2 weeks, Devram Gunduz, one of the packagers for the Postgres community, will join us to talk about platform native packages. And then on April 15th, Bruce is going to talk about window functions in Postgres. Again, a really, really interesting and very technical talk, great for developers. It's a very, very noteworthy feature.
Mark, this is our first coronavirus quarantine webinar.
It is. You know, we're all doing this from home, and you know, we hope that all of our attendees here are safe, and that this way we can continue our ongoing interaction with our Postgres audience. And looking at the number of attendees and the number of people who registered, this appears to be a very well working model. So before we get into the meat here a little bit, this is just the agenda. We're done talking about postgresql.conf, how to work with it. Raghav's going to explain something very important to us, which is the change context, help everybody understand which parameters you can change and just apply by reloading, so without restarting the server, where you need to restart and which parameters actually need to be changed by an EDB packager or somebody who compiles their own settings. I'm going to go through tuning recommendations, tuning tools, and then we're going to talk a little bit about who EDB is, and we're going to do that at the end so that we can dive into the meat of the presentation as fast as we can. Okay, so Molly, I think you had a little Q&A here for us.
So today, before we get started, we're going to have a little poll on how well do you understand postgresql.conf. So we're going to give everyone a little bit of time to vote. Your options are: I have a complete understanding, I find it confusing, I don't really know how to tune, or I don't know anything about postgresql.conf. So right now, we've had about 25% of the audience voted in the first 20 seconds. We're just about to hit 50%. I'm going to give it a few more seconds.
You know, Molly, on any given day, I can click any of these actually. Like some days I find it, I like completely understand it, and the next day I'm like, what? That's really confusing. And then other thing, I can't even find the file. So I can totally click any of those.
It's like the days, every single day, it's like you're learning something else. We have 80% of the audience voted. I'm going to give it one more second. All right, so I'm going to share the results. Here is how everyone voted.
Yeah, so, sometimes when I'm confused, I have to actually look at the source code to figure out what it does. And obviously, 99.9% of people aren't going to do that. So that's when we need to improve the documentation, or something needs to happen to make it easier. So this is, as you know, we've had this file forever, but this is an ongoing improvement process that we always work on.
Yeah, and I think Raghav's going to give us a good step-by-step approach for how to do that. And I know he's also got an upcoming blog on, exactly how to do it. So hopefully we can reduce some of that confusion today, because there's a lot of knobs, there's a lot of levers you can pull. But hopefully we can walk you through what are the top things and help those today, by far the majority who are not completely comfortable with postgresql.conf. Okay, so let's turn it over to Raghav and let's roll.
Yeah, here we go. Raghav, when you are ready.
Okay, can you see my screen now?
Absolutely.
Okay. First of all, thank you everyone for joining, and thank you, Mark, Bruce, to be part of this webinar. We're going to talk about how to tune Postgres server. So in this webinar, I'm going to give very high-level context, like how to tune, where to tune, and what are the tuning tools we have, and other recommendations that you can get from Bruce and anybody from our ADB staff. So covering all the parameters or covering everything in 40 minutes, I don't think it is possible, but what I try to give here is a very high-level picture where you all can edit and tune and at least do a basic changes to the Postgres server. So first, I'll talk about postgresql.conf. So like other databases, there is a configuration file where you can adjust your resources. Same way for Postgres also, we have a configuration file. That file is called postgresql.conf. There are 2 to 3 more configuration files in the cluster, but postgresql.conf file is the one where it specifies the server behavior, like how many connections, how much memory you have to allocate, what would be the logging, vacuuming, related parameters, and it completely sets the behavior of your PostgreSQL server. Now, where do you find this postgresql.conf file? It's in a cluster. So in Postgres world, like we call data directory as a cluster. So in that cluster, you'll have a postgresql.conf file. Some distros will put in /etc, but generally it's in a PG data, we call. And it's a simple plain text. You can edit and you can see all the parameters and you can set the values there. There is, if you edit a postgresql.conf file, there are some pound signs. That means that parameter is with the default. That means if you want to tune that parameter, you need to uncomment that, remove that pound sign, and then do changes. And next is every parameter will come with a default value, and those values has to be changed according to the recommendation given to the right side of the parameter. So it's a very user-friendly open text file where you can edit and you can read the context of the parameter, and then you can do the changes. And I did a simple graph. I see there are more than 270 plus parameters in that conf file. So what are these? Like it's related to every area. Like one is related to connection, memory, related to the replication, vacuuming, logging, many more things. We'll see next in the slides, like what are the parameters are there and how to tune that. So
let me ask you one question, Rag. These,
Yep.
the postgresql.conf file and everything that you're going to tell us now, is that equally applicable to EDB Postgres Advanced Server, the Oracle compatible version of Postgres, and PostgreSQL, or is it specific about PostgreSQL?
It's applicable to both. So the conf file is there in Advanced Server as well as PostgreSQL Server. In Advanced Server, you'll have more GUCs where you have a very good tuning parameters in that.
Thank you.
Yep. So how do you interact with the postgresql.conf file? It's very simple. Like you need to edit the postgresql.conf file, and first every line will have a name and a value. Okay, if you see my here, it says a parameter name and what value you have to set. Very simple that way it is. Name is a parameter that you want to tune. There is also called a GUC. In some of the community emails, you will see PostgreSQL GUC. So it's basically they are referring to the parameter. Okay, so that means that parameter exists or not exists. That way they refer to that. And a value. Value is a unit that parameter accepts. That means it could be a Boolean, integer, or float units like KB, MB. So if you want to do some memory tuning, right, the time the units are in KB, MBs. And if you want to do some logging, like query-related logging, you want to log a query that is taking more than 5 seconds or 10 seconds, then that unit is in time. Okay. Sometimes you want to allow a server to with multiple IP addresses, then there is a string or a list like that. So these are some of the values that parameter will accept. So here, no need to confuse, because every parameter, the right side of the parameter, there is a comment section. It's clearly given, like, you know, what are the unit values are accepted. So you can see the right side and do the changes accordingly. Okay. I'm giving a small example. For example, if I want to change a memory parameter like shared buffers, this is how I need to give. So left side is a value name, and right side is your unit. And this is how you have to set. Now going forward, so this is about a postgresql.conf file. How you set this one. Now, now you need to understand. Okay, if I edit and do the changes to the postgresql.conf file, will it apply immediately, or do I need to do something to those parameters, or what are the changes are required to that? So that is what this context is. So whenever you do changes to postgresql.conf file, you need 2 to 3 things. One is you need to simply do a reload. That means just reloading the server, the changes are applied. Next is restart. That means you need to completely stop the server and restart to apply the changes. And there are some parameters that you cannot reload or restart, that needs a recompile. So you don't know all these contexts, right? So there is a query in PostgreSQL, like PG settings context. It will tell what are the allowed change context this parameter is. So there are hardly 6 to 7 contexts for each parameter. One is internal. That means if you see a parameter that is mentioned as internal, that means this is not allowed by editing or by just reloading or restarting. That means you need to do all this at a compilation time. That means you need to change this parameter at compilation time. You might be thinking, like, you know, when you all using RPMs and one bundle installations. Some people will do with the compilation version also at the time they do the changes. So for those, they can change with that parameter. And next is postmaster. Postmaster means it's a main daemon process. It's a parent process when the server started. So if a parameter is shown as a postmaster, that means it needs a restart. So the parent process has to know what changes you are doing. Okay. Next is sign up. Sorry, there's a spelling mistake there. So it's a reload. That means whenever you do the changes to the server, you just need to do a reload. No need to do a restart. Okay. So after the ongoing session, the next sessions will take the new changes that you have made to the Postgres parameter. Next is backend. It's a similar to sign up. And next is super user backend. That means in the session, how this setting is changed. And next is super user. Some of the changes that database super user can do it. That level of the information is given to that parameter. And next is user. That means in a session, every user can change it. For example, if you open a session and you want to change the behavior of a query, like you want your query to use an index scan. So you can enable few of the parameters in the session and then run your query. So you can see what's happening to that query. So that is at a session level. One, that means you connect via PSQL, begin a transaction block, do some changes using a set parameter, and then run your query and exit. That is at a session level. So whether the session level changes are allowed or not, you can see by running a query called select distinct context in page settings. And that way you will see what that parameter is. If you see at the right side of the slide, there is a query. I want to see log connection information. So there you can easily make it out. Okay, this setting is for super user backend. Okay, and pending restart. That means if somebody has already changed using alter system or some command, if it is not at restart, then it will tell what it is. So these are some queries, and this is the context you need to know about each and parameter before you tune it. Okay. Now what next? Like is after you edited a postgresql.conf file, you made some changes to the parameters, then how do you apply it? Okay, there are two ways, as I said. One is reload, one is restart. So reload means once you can connect to the database and simply call a function, a system-defined function. It is pgreload conf. This is a classic method we used to use. pgctl-d, that is another way. From the OS terminal, you can simply run a reload. So it will reload the configuration file. And there is another method, or Linux method, like you can call on a postmaster. That is also a reload. But the recommended approach is always use pgctl-d or some systemctl or pg reload_conf. And restart is by using OS complete restart. OS services also restart, or you can use pgctl to restart. So by these two methods, what will happen is the changes what you made to the postgresql.conf file are applied. And there are few parameters you don't want to change for entire cluster or all the users or for all the databases. Now you might be thinking like, why don't I set a connection limit to one database to one user? Yes, that is also possible, but how you do it is you need to run an alter database or alter user or alter system. Using these system commands, utility commands, you can set the parameter per database, per user, and at a session level. Now you don't want all these changes. For example, before doing these changes, you want to see the impact of it or how the behavior will be. Then you can do it at a session level. That means see what are the session level parameters are supported. Open a transaction, set the parameter, complete your work, and then close. And see if that is giving a proper result. Then you can edit a postgresql.conf file, do the changes, and follow the procedure like reload or restart as mentioned. Okay, this is how you change postgresql.conf file, and this is how you apply it. Next is classification. Like there are 8 to 9 classifications in the postgresql.conf file. So I will give a very high-level picture of what and where, which location you have to tune, because in the time you cannot brief about all these parameters because it takes a lot of time to explain this. And there are other components involved here, like how do you do your benchmarking and all that. So that's why I will go very high level, give a high level picture of way to tune the parameters. So first is file location. If you open a postgresql.conf file, the first is file location. That means the server need to know where the configuration files are. So that information is in configuration file location section. So where is your host-based file, where is your ident, and where is the data directory, and that information is there in the file location section. Next is connection and authentication. So once a server is started, it has to listen on one TCP IP. So where is that connection details is listen underscore address, where you tell on which server it has to, which IP it has to listen, and on which port, how many connections it has to start, and how many will be a super user, like that. And next is TCP control, if you have a network related, so that parameters you can see under TCP control section. Next is security. This is a very big area because today we have because it supports in the latest version SSL, and there's so many varieties of security levels supported in Postgres. So this could be a different webinar altogether, but this is the area where you can enable SSL, Kerberos, and many more. So this section is purely related to authentication. Now, next is resource usage. Here, most of the people will get confused because they will be coming from the different databases and they don't know where to tune and how to adjust the resources. So my recommendation here is what I've seen is 80% of the new installation and all that, the Postgres will work just fine. You need a tuning when you increase your workload, or when you have some capacity planning or unexpected growth in your IOPS and all this. In that cases, you need to do a tuning. So if you want to tune your server, I would say start from very decent settings that are available, that are with your close to your resources allocated on the server, and then gradually increase after doing a proper benchmarking and stress testing on the server, and then take the numbers and adjust these parameters. So directly you should not come over here and do the changes to the memory and all that because it's not recommended, because there are different components, your CPU behavior, your disk behavior, and how the memory is used. And sometimes your application may be doing some crazy things, like it opens up a transaction and never closes it. And so you need to understand from all the areas and then come over here and then tune it. So I'll give you a general idea, like how do you tune here is, so there is a memory area, like other databases, you don't have separate sections here. There is a very few memory areas here, like shared buffers, where the data is write operations are performed, like the temp buffers, workman for sorting, maintenance workman. That means you have a maintenance. That means in Postgres you need to do some maintenance, like MVCC. Due to the MVCC concept, there's a lot of cleanup work has to be done. So for that there is a memory, and to do that cleanup there are auto vacuum processes. That means automatically there is an auto vacuum will come and do the cleanup work. So for that, these are the set of areas. These are the set of the parameters that you need to tune related to the memory. And disk and kernel, sometimes you are trying to run a query, and the query is a sort query, and the memory what you are using may not be sufficient to perform that query. There will be a chances of disk swapping to avoid that, like how to control and what all that is, like temp file limit. It creates some temp files, so you need to know how much temp files it has to create and how many files it has to open. So that level of information is these two parameters. And next is, as I said, like you need to, there is auto vacuum, there is also manual vacuum. That means Postgres has a vacuum, auto vacuum by default. That means the cleanup work is taken in background without user intervention. That means the most of the cleanup work is done by auto vacuum. So if you want to do a manual vacuum, that means explicitly call a vacuum utility, then these are the parameters that you need to tune. And apart from that, there is a write operation. That means what are the modifications you do in Postgres server, on a Postgres server, that modification has to be written to the disk. So there you need a background writer. That means that is BG writer related parameter space. Next is when you run a query, there's a parallel mechanism. That means by default, the background workers are multiplied and your query is executed. So these are the three areas where you control your resources. So we'll go in detail in our recommendation section on this. Next is write ahead log. This is a very important one. It calls because it's a transaction block. This is the one place where most of things are related. One is about your transaction level, that how well your transaction is supported on the database, as well as archiving, checkpoint and archiving. Using these transaction logs, your replication is dependent. That means this sometimes, though today we have a stream replication, but still these archives are required for some other replication system. And this is also required for a point-in-time recovery. So we call it as a write ahead log. These are transaction logs. So here you need to set val level, like how much data should be written to the transaction log. That is controlled with val level. Fsync, synchronization between your file to disk, memory to disk, and synchronous commit. So like that, these are the set of the parameters that related to your transaction logs. And checkpoint. So any updated data in the buffer should be written back to the disk. So checkpoint related. And archiving. You can archive the transaction log. That means make a copy of these transaction logs. So you can use archive_more on and set the command so that another copy is written to the another area. Next is archive and recovery target. From 12 version onwards, there is no recovery.conf file. So most of the data is inside the postgresql.conf file. I mean, most of the parameters. So this will tell how the recovery should be. So all the recovery related parameters are in under archive and recovery target section. Next is replication. Replication related parameters. These are the replication related parameters. There are a variety of replications in Postgres today. Good that we can do a full replication, we can do a partial replication. So like that, we have a publication and subscribers, so that related parameters. And we have standbys. So standby, like hot standby, like that, we have you can set all the standard related parameters. And we have a cascading functionality. That means from one master to one standby to another standby. Like that, we can do a cascading. So those related parameters are under this section. Okay. Now, this is related to your memory usage and replication. Now, coming back to query tuning. So this is another important area. Like once you spin up a Postgres instance and you did all the memory related changes and everything, now you need to know how your application is performing. That means application will run some queries, and you need to know how the queries are doing. So for that, you need to adjust a planner, like which plan it has to pick and how that query has to be performed. Next is a planner constant. That means it's so here I would say, like if your query is not performing, you need to see the plan first and see the routes, like is it going to in a sequential scan or index scan. So you can control that one with this planner constant. So here it talks about sequential page cost and random page cost, CPU cost. So these are some of the parameters that will control the behavior of your optimizer. So I will come to this section because we have few of the parameters in our recommendation section where we can discuss. And next is you have a genetic planner here, and we have other planner options like cursor tuple fraction. So these are some of the planner related parameters. And after doing a proper query planning, then you need to come back to reporting and logging. This is another important where DBAs can see really what's happening on the server. That means you have done some changes to the memory, you have done some changes to the connections, you have set the optimizer, you have a replication on the server. Once this is all there, you need to know what's happening on the server. So how that is possible is you need to do a proper logging. So how do you log is there are a variety of logging parameters in postgresql, where to log, when to log, and what to log, and properly defined. So if you see these parameters, you can see okay where to log. That means where your log file should be and how much size it should be. And next is when to log. That means do you want the transaction to be logged before or after? So that way you can control. And what is the error level? And you want the full statement, time duration, and all the other details like connection, disconnection. So that information is going to log. What to log is like in a deep, very higher level, like checkpoints related detail, auto vacuum detail, and everything is written, replication related, everything is written what to log. And there is a log line prefix, which is very important, where it will tell at what time, by which user, on which database, and which time. That information is clearly written per line basis. So this is important because on this basis, there are so many tools that will read your log file and give a dashboard view to you so that you can see what is happening on the server, or you can also load back to some other analytical databases and then see how the process server is performing. So this logging is important. So these are the set of the parameters related to the logging. And next is statistics. Statistics is very important because you may not see everything in logs, because log is in a post activity. That means when you run a query, that query is written in the log after completion. So there are some parameters. If you enable it before, you can write it, but most of the time people won't do that because it will fill your log. So that's why they prefer to log after certain duration. That means you run a query, and if the query taking more than 5 seconds, then you set that duration. After that 5 seconds, the query is logged in the log file. Now you don't know what until that time is completed, what query is executed. Now, if you want to know before, right, you need to have a stats. That means in Postgres there are pgstat and pgstatio. These are the two views. In that family, you have so many variety of views. That means you can run pg_stat, a list of views. You can see what the query is running, or is your archiving is running fine or not, what is the auto vacuum status, what is the number of connection status. All this information is given in pg_stat views. To get the data to that view is right, these are the parameters that has to be enabled. So these parameters by default enabled, but you can do the tuning to these parameters also. And same way for monitoring also, you can extend your logging. Like for example, it may write a query there, but you want to know the details of the query, like how the parser has executed and what are the bind variables and all that kind of information you want to write. Then you need to enable this section. Now, next is auto vacuum. As I said, auto vacuum is by default enabled. That means whenever auto vacuum executes runs on a Postgres server, it will write what all it has cleaned. So you need to enable that logging, and if it has to do more work on a particular table, that means do more cleanup work, then there is a workers, like it will spawn multiple child workers and then do that cleaning work. So there is a control here. This is like a table level, and it will change the table stats, and it will update. It will do the cleanup as well, and it will update that. So this is auto vacuum related. Next is client connection defaults. So the behavior of a client, that means whenever client connects, how much time it has to wait for the connection, and once he is executing some statements, how much time he can execute. That means he cannot run a full scan query that will take 4 to 5 hours on a production system. So how do you control is like statement timeout. So that kind of information is your statement behavior. Next is locally, like you can change your locally settings, formatting, also date style, and that related information. Next is shared library reloading. That means you will be enabling some of the modules on the servers. So this is the location where you can use to load the libraries. So this is about the conf file that is related to more of memory, logging, auto vacuuming, resources, and everything. This is the last part where you need to know about the lock management, like how the read logs happen in Postgres, and that kind of information you can tune in lock management. And next is version platform and error handling. So what should happen on exit, that kind of information you can control in this section. Next is config file include. This so far we were discussing about postgresql.conf file, right? These are some of the parameters, but you may be thinking like, okay, there are 200 plus parameters in postgres. How can I keep track of all these parameter changes? So you can create your own conf file, one small conf file where you can add a set of parameters, and that you can include it in an include section. So that means first precedence is taken to the postgresql.conf file, and after that the new file what you have added, that is executed. So this is the way how you can keep a small conf file separate with your postgresql conf file, and on that basis you can modify your configuration file. So these are the classifications. How there are many classifications. Sorry, I couldn't able to go in detail about all this because of the time constraint. But if you go through this slide, you can see where you can tune. If you get confused, also you can see. Okay, you are talking to lock management, then you can go to the lock management area and you can tune that. Now, coming to some tuning recommendations here. These are very basic recommendations we are giving because there are, as I said, many components are involved. You need to do a proper benchmarking, stress testing on your server. You need to know the numbers of your hardware, and then you need to come back and tune the Postgres. But straight away, you can't say like, oh, I have a very good SAN, I can come and tune it. No, that is not the way. You need to know the SAN numbers first. Same way you need to know the CPU. Same way you need to know your memory and your application behavior also sometimes. After you arrive to one good number, then you need to come back and do the tuning. And tuning is like a investigation. Like you cannot straight away tune at one time and you cannot expect a result there. So you need to do that multiple times and different cycles with different parameters and different numbers, and then you can arrive to, okay, this is the way I need to tune, and this is the best output I can get on this server with this tuning. So that's why I'm giving very basic recommendations here. So first is a shared buffer. The recommendation is up to 15 to 25% of your available RAM. That is recommended. Why shared buffers? Because here most of the write operation will happen. So whenever you're doing write, like inserts, update, deletes, everything will go into the shared buffers. And next is maintenance work mem. This is for your index creation. This is for your auto vacuum. This is for your manual vacuum utility. And if you're trying to create index, that is also, this memory is also used. So you need to adjust this memory when you're, so on the server. So this memory is used whenever those utilities are called. Same way as workmem. Workmem is for sorting purpose. So this should be 0.25 divided by max connections. These are some, to start with, these are the recommendations I'm giving. Next is max connections. By default is 100. You can go with a pooler, but don't try to increase this number to above 500 or something like that. Better first know the connection settings, connection requirement from the application, and then make use of a pooler. So that will have a uh, default connections that application can use, and when required, it will come to the server. So prefer connection pooler. Next is effective cache size. This will help an optimizer to pick the index or to do a proper plan. So this is 75% of your total RAM. Next is val buffer. This is 132nd. By default, it is 16 MB. So it can be increased up to 32 MB. But let's start with 16 MB. And BG writer by default is 200 milliseconds. So this is a round circle, how many times it has to write from your shared buffers to the disk. Okay, so lower it so that if you have heavy writes, it will go very quickly and write to the disk. Same thing with BG writer max pages as well as multiplier. Next is val level. This is related to the replication. By default, it is 15 to 20. Oh, sorry, this is to replica. I need to change this one. Sorry for this. By default, the val level is replica. That means maximum is written. You can change to minimal or logical as per the replication requirement. You need to change this one. And min val size and max val size. So number of files it has to maintain in a cluster. That means every data directory will have a PG log, PG logs, transaction logs. So you need to set those many log files where your standby can consume even after checkpoint. So that way you need to adjust this. Next is checkpoint completion target. Keep a higher value for the smoother IO. And next is checkpoint timeout. This is also for the checkpoint, how many times it has to go and write to the disk from your val buffers, next is a random page cost and CPU tuple cost. So these are the two related to the optimizers. So as I've told, so adjust this one so that the index scan is given higher preference. Next, come back. Last thing is about the tools. In tools section, there are few tools that you can automatically use to tune it. For example, PG Tune is the one I prefer. I've seen this one because you can give a number of connections, resources, and all that. It will automatically tune and give it to you. Next is a log analyzer. This is for reading your log files and then giving a statistical view. And if you have installed Postgres Enterprise Manager, that will tune your server. That means it will read, because there are some agents. There are agents when you install Postgres Enterprise Manager, it will automatically read your server resources and all that, and then it will give an expert advice of what the tuning should be there. If you give a permission, it will apply and it will bounce the cluster also. And these are some useful links that you can refer for tuning. So these are very good examples.
Bruce, is there something on your website? I know you have an extensive list of presentations, etc., that talk about some of these things. Is there additional reading that you would recommend to somebody who's really digging into this?
Yeah, probably two places on my site. I have a categorized blog list, so the 500 and some blogs that I've done, there's categories that dive into a lot of these things like wall size and auto vacuum and setting these values at various levels. Plus, I have an administration talk which goes into some of the details of what these things are actually doing internally. Both the performance talk and the admin talk probably would have information, as well as the optimizer talk that I have. So there's a lot of stuff on my website. This is a great sort of presentation. I know I would love if we had no tuning at all. Like, wouldn't it be great if we could just get rid of the file? right? And just say, Postgres is going to do exactly what you want all the time. And having been at this, for 24 years, there's always this trade-off between adding a setting and then requiring people to review that setting or potentially decide if they want to change it. So we're always trying to reduce the number of settings, but at the same time, we have to expand it because we can't always automatically do what everyone wants us to do. And it's this tension between those two that I'm always struggling with. In fact, I have a blog, really odd one, that talks about there's sort of an optimal number of settings that you should have for a server. And if you have fewer than that, then your server's not configurable enough. But if you have too many, then your server becomes too complicated and too hard to manage. And different databases go different ways. Like, for example, Oracle is much more they have a parameter for almost everything because effectively marketing said if you add this parameter, somebody else will buy it, right? But then there's other databases that have very few settings, particularly in the NoSQL space, and you can't really get it as flexible as you need it. So there's always that tension. And I would I'd love not to have a config file, but I think we have probably the right number, plus or minus 20. There's probably 10 or 20 I'd love to get rid of. But and again, a lot of people, unless you need something or you need high performance, a lot of people just leave it. I remember being I was at a round table in Amsterdam with a whole bunch of Oracle experts, and we were explaining why Postgres doesn't have as many tuning parameters as Oracle. And they kind of beat on us. There's no parameter for this. There's no parameter for that. I'm like, I understand Postgres is a generic database. We don't assume you're going to have a DBA and so forth. And then the guy who was the smartest in the group, and everyone knew it, he said, I have to admit, every time I go into an Oracle customer, 95% of the config files have never changed. So he said the idea that we don't that Postgres doesn't have parameter for X is not necessarily a bad thing because we're the Oracle geeks who love those settings, but the average person really just wants the database to work, and in most cases there's only 2 or 3 or 5 that maybe you want to play with to get maybe better performance. But even then, most databases are idle, and Postgres is durable by default. It's very standards compliant. It doesn't run out of resources. It doesn't require a lot of hand holding, and that's why a lot of people are like, it's running fine. I don't want to minimize the great presentation and all the details because you may need these someday. But at the same time, there's only probably 5 of them that the average person even changes in their setup.
Okay, Molly, back to you.
Yes. So one quick thing before we go to the question and about EDB section of our webinar, I have a quick poll for everyone. I'm going to give everyone some time to read and answer. On a scale of 1 to 10, how likely are you to recommend this webinar? 1, not likely at all, or 10, extremely likely. I'm going to give everyone a few seconds to answer. Thank you again to our speakers today. You are all amazing. I'm going to give it another 5 seconds. We've had 65% of the audience voted. Alrighty, all right. So we're going to get into the next part of our webinar. I'm going to share my screen.
Okay, and I promise to everybody we'll be very quick about this because obviously we want to get the time to get to the questions. Molly?
Yes. Okay.
All right. Okay, not a problem. Present.
Yeah. Present. Everyone.
All right. So okay, and so while this is loading, Postgres. For those of you that may still have any doubt about Postgres, Postgres has been in the Magic Quadrant, Gartner Magic Quadrant now for 6 years or 7 years. Yeah, it's in there as Enterprise DB, but at the heart, it's Postgres. And so that really shows that it has the oomph and the capabilities that enterprises are looking for today. If anybody wants to have a copy of the the Magic Quadrant report to make the argument to their CIO or their management that they should be, that it's okay to build on Postgres and you're not going to get fired for building on Postgres. Well, maybe even you should get fired for not using Postgres, right? So if somebody wants to make that argument, let us know. We'll send you a copy of the Gartner Magic Quadrant. Let's go forward. Okay. And we've been active with lots of customers, and I'm not going to go through this list here. The argument is only that Raghav's points and the details that you're reading in Bruce's blogs, they've not just been made up, right? We've been in this Postgres business now for 16 years, been regular contributors as EDB to the Postgres community for 14 years. I think, Raghav, you've been with Postgres for over 10 years. Bruce has been driving Postgres forward for 25 years. So the recommendations that we make here and the statements that we make are based in experience and in work with really large customers. Let's go forward. Okay. We're also very active in the Postgres community. For anybody who has dealt with the Postgres community, you'll know a lot of these names. Obviously, Bruce, Bruce and Dave being active in the core team, overall making sure that the Postgres processes happen. And then we have people like Robert and Amit and Devram who are major contributors. Robert and Amit are committers together with Bruce to the code so they can actually make the changes in the source code. And then we have lots of named other contributors to Postgres, such as Rushab and Amit and others, and also adjacencies like PG admin, where Dave is very active, and then Akshay and Ashesh very active in Postgres and in the adjacent communities. Let's go forward. Okay. So really what we do is, a lot of work in the database, but then also the tools that you need for high availability, for disaster recovery, management, the support and the services, etc. So that's all the things that EDB brings to the table. Okay, now without much further ado, I want to get into the questions because I think we got quite a few of them, and maybe go forward one more slide to the call to action, please. While we work on the questions here, if you need help with Postgres, we offer services like remote DBA or DBA services in the cloud and on premises, consulting services. If you have any questions or want some help, especially in these trying times, to operate your Postgres remotely, be as successful as you can, don't hesitate reaching out. Okay, now let's go to questions.
Yes, so we had a ton of questions. The first one I'm going to ask today is there a data dictionary view that will list the currently configured parameters when it comes to team name?
Yes, there is a PG settings view that you can query. In fact, I'm looking at it on my other screen because Raghav it mentioned this category I hadn't heard before, which was internal. So I was curious what internal settings we have, and wall block size is one of them. So if you do select star from PG settings, PG_settings, you'll see all the settings. You'll see their defaults. You'll see the exactly what Raghav talked about, the level that setting is at, the category that setting is at. You can also do show all from SQL. That'll give you a shorter description. So both show all and select star for PG settings are available.
All right, great. Another question we had come in is, does Postgres support SSL, PostgresQL support SSL, or will it in the future?
We've always supported SSL. We've supported IPv6 for probably 16 years, I think. So we're continuing to improve our SSL support, although because the security requirements keep changing. I think we just added, for example, the ability to specify a minimum SSL and a maximum SSL protocol value. So if you want to say, I don't want to support 1.1 anymore, or 1.0, you can actually do that by configuring it in the server.
Okay, great. Another question we had come in was, can you change the log location after the initial cluster is built?
Yes, we can change the log location. There is a log underscore directory. Using that parameter, we can change the location of the logging.
Okay, great. And then I believe we have one more question today. Okay, yes, the last question. People keep writing in. Bruce, what is your blog site? Do you know the URL for it? Is it just brucemomgen.com?
It's
Momgen.us.
momgen.us. Yeah.
Yeah.
All right, so if you're looking for any of the blogs that Bruce mentioned today, momgen.us. We had a ton of questions. We even have more questions rolling in right now, but we are coming up on our time. So thank you to everyone who stayed today and listened to our webinar. Apologies to those whose questions went unanswered. We will be answering them in the follow-up, which you'll receive in a couple of days. Thank you, everyone, again. Stay safe out there and have a great day.
Thank you. Thank you.